Welcome to all. This is class 7 for general public, and for those who are in the RCC group, it is class 20B. Remember, reason I told you in the class. Okay. So far, our class number 1 to class number 6, we considered singly reinforced section. Now, analysis of doubly reinforced rectangular section by working stress method. All principles told yesterday. Yesterday means last class. So, I will give example. Today I decided only where technique is not required, I will write first in the board. Whereas where technique is there, I will write in front of you only, just for a change. It won't take much time. Okay, now start. Question dictated in the class. This is question is, remember, Roman 1. Earlier Roman 1 was for singly. For doubly, Roman 1, there is no ABCD, only one question. Why? Because only one question, no further questions. Roman 1, make a note. Roman 1 is for finding stresses developed for given bending moment. Already told last time. Okay, start. Question. It is not MR. A rectangular section of a RC beam, 250 mm wide and 650 mm deep, is subjected to sagging BM. So, remember, sagging BM told, so top compression, bottom tension. Suppose hogging means nothing to worry, same answer will come. Where you put AST, you put ASC. Where AST is there, put AST is there, put ASC. And X and D measure from bottom edge, that is always from compression edge. Okay. So question is subjected to sagging BM of how much? I told somewhere. Yes, 125 kilonewton meter. Okay. Now, the beam is reinforced on tension side by 3 bars of 20 mm diameter. See, I am not giving 20 torr, etc. Why? We are not, what grade of steel does not matter. Why? Because you are applying bending moment. What is the grade of concrete? What is the grade of steel that you require when you go to strength? Here strength is not counted. As I told, eat and pay. So the beam is reinforced on tension side by 3 bars of 20 mm diameter at clear cover of 45 mm and compression side by 3 bars of 16 mm diameter. Here clear cover is 40 mm. Just I am changing the cover. Over. Now, see, I am not giving what is grade of concrete and what is grade of steel. But you require modular ratio. Either they should give grade of concrete so that you can find M by 280 by 3 sigma CBC, or they should give M. Okay, in this question, I am giving it. Take modular ratio M equal to 11. I will tell you one thing. It is actually M25 concrete. 10.98 will come. Somebody round it to 11. Okay, done. So, over. Now, we will start solution. Those who want, I will read the question once again. Because sometimes, as I give the question, I keep talking in between. Okay. Some will tell, sir, we are not able to write. Okay, right. A rectangular section of a RC beam, 250 mm wide, 650 mm deep, is reinforced on tension side by 3 bars of 20 mm diameter at a clear cover of 45 mm and on compression side by 3 bars of 16 mm diameter at a clear cover of 40 mm. The beam cross section is subjected to a sagging BM of 125 kilonewton meter. Find, this I not told earlier, maximum compressive stress developed in concrete and also stresses developed in both the steel. So therefore, see, required is maximum compressive stress developed in concrete, remember FCBC, and stress developed in steel in tension, that symbol is FST, and also they want stress in compression steel when cross section is subjected to this bending moment. Okay, now start as usual. Those who are serious, write width of beam B 250 millimeter. effective depth D, 650 minus 45 minus 20 by 2, 595 millimeter. Area of steel in tension, pi by 4 of 20 square into 3. Area of steel in compression, pi by 4 of 16 square into 3. Then you need one more term, effective cover to compression steel. See, effective cover to compression steel. Extreme compression edge. See, ECE means what? Extreme compression edge to center of compression steel. 40 clear cover plus half of 16, 16 by 2, 48. In the question given, M equal 11 class, I told about this one, over. Required find, I already told. Irrespective of finding moment of resistance, which is not doing today, or stresses developed for given bending moment, first is always locate neutral axis. Okay, start. Location of neutral axis. That is to find X. Depth of neutral axis from extreme compression edge. See here, this is X. Equation I told last time. I read once again, but not by hearting. Bx into Bx square by 2 plus MC minus 1 ASC into X minus D dash equal to MAST into D minus X. MC is modular ratio on compression side. I told M to be applied to tension steel, for compression steel, MC to be applied. The reason all told in the regular class. Here I cannot tell those things. So MC as per IS code, MC equal to 1.5 M, 1.5 into 11 is 16.5. Now substitute. B 250 X square by 2 plus 16.5 minus 1 into ASC 603.19 into X minus D dash 48 equal to 11 into 942.48 into D is 595 minus X is X you are calculating. Solve the quadratic equation, rearrange. Sometimes in the online class I have seen people simplify, solve. They should not do it. Somebody studying structural engineering subject, if he does not know how to solve quadratic equation, he is not fit even to see the title of the class. Okay. X will come 164.358 millimeter. Now continued, 1 minute before continuing, one note. Last time I am telling, already this told many times. When you are, I will not tell again and again now. That is, there is a limit for everything. When you are finding stresses developed for given bending moment, left hand side write M, right hand side write stresses developed. Never bother about what? What is the permissible limit? So here balance section, under reinforced, over reinforced, permissible stress, none of this will come. But remember, see color changes, green color. All these factors will come later when you go to MR. MR means what? Resisting capacity. Then it will come. If you eat randomly, you have to pay for whatever you have ordered. But if you want to safely eat, first check the money. Then you should know how much money you are having. This all I told, I think maybe 10th or 11th time in the class. So now, this all I will maintain. See, I will make a note here, how much X I got. Because I am rubbing everything. 164.358 millimeter. Okay. I got the value of X. Now, this all, I will maintain this side. I use that side. Okay, X I got. Now, continue. This time, I will write everything in front of you only. Okay. This I will remove now. Little problem. If I take a break and write once again, I can clean the board more neatly. Now, little, this all not required. Little stain will be there. Okay, no problem. What is there? Okay, now start. Already told, we are X is there. See, actually I tell you here, we got X equal to, I will not use blue color now, color problem, 164.358 millimeter. Usually I write blue color, today no, I have searched for the pen limit. Color is okay. Now continue. Now write. We have, first always, first find one note. always first find FCBC, because for doubly reinforced section, M expression is generally written in terms of compression. Some people will tell you cannot write in tension. I will prove it to be wrong. You can write, but remember, make a note. Of course, it is possible to write in terms of tension, but it will involve lengthy calculation. So when there is a lengthy calculation, who wants to waste time? So singly reinforced, right? You have got both M in terms of C, compression, and M in terms of tension. But doubly reinforced, universally, M is written in terms of compression. That is, we have M equal to, see, M is the bending moment for cross section. Bx FCBC by 2 into D minus X by 3, not over. This is for singly reinforced section. If doubly, more terms, plus MC minus 1 into ASC. As I write every term, I am imagining, just now I finish. See, when I wrote B into X, to my mind, compression area comes. When I put FCBC by 2, to my mind, average stress comes. Multiply area with the stress, I get the compression force. When I put X by 3, I can see where is the line of action. When I subtract X by 3 from D, I can see a lever arm. So force into lever arm is M. That's why not by hearted. When I put MC minus 1 ASC, I can imagine steel area in terms of equivalent concrete into stress there, FC dash. Now, this will give me area into stress force. Lever arm is D minus, from there, D dash. That's why, if you know the basic principle correctly, then you don't have to by heart. This will come naturally. Okay, start now. FCBC is what? This is maximum compressive stress developed in concrete. Developed in concrete when given cross section is subjected to bending moment M. Okay, this is all I told you. Now we want to find FCBC. We have to find this one. So M is known. There is one problem here. What? If it is a single reinforced section, substituting, you get the answer. But doubly reinforced section, problem is that there is one more unknown, FC dash. Notice now, see, now, to get FC dash. How to get FC dash? See, use, I already told you, consider compressive stress diagram. Only compressive stress diagram. See, this is neutral axis. This is your X. This is your FCBC. From here, come further this side by D dash. When you come here, what stress comes is FC dash. So, but I'll tell you, what is FC dash? FC dash is compressive stress. Remember, in concrete, not steel. In concrete, at the level of centroid of compression steel ASC. Okay. Now, if this is D dash, this will become X minus D dash. From similar triangles, what you get? FC dash by, you can write FC dash by X minus D dash equal to FCBC divided by X. Or you can tell FC dash equal to FCBC into X minus D dash divided by X. This I told you last time, if you remember, in the theory class, in class number 7 I think. I told this, previous class, I told this one. Or substituting equal to FCBC is FCBC only. I didn't know space there, I write here. So FC dash equal to FCBC into X. Where is X? 164.2 358 minus 48 divided by 164.358. Therefore, what will happen? Your FC dash will come in terms of FCBC. Okay. That will come. I have to calculate. Where's the calculator? I think I is here. Otherwise, again, I have to go back. Okay. Okay. This today, I think in your class, first time I am calculating. Okay, no problem. Minus effective over 48 divided by neutral axis depth. 0.70795 or 0.708. Okay. 0.708. 0.708 is FCBC. Okay. Now, remember, FC dash equal to 0.708 FCBC. Now I will do one thing now. Because I want to substitute this bottom portion, I will remove. So this much you have to write. Then continue once again. That much you can make out. Because today I am writing in front of you only. Now, substituting, what will happen? M. 125 10 to the power 6 kilonewton meter converted to Newton millimeter equal to B. 250 into X. 164.358 into FCBC divided by 2 into 595 minus 164.358 divided by 3 plus, continue, see here, continue, plus MC minus 1, 16.5 minus 1 into ASC. ASC is 603.19 into FC dash is 0.708 FC into D is 595 minus 48. What will happen? FCBC here, FCBC. Ayo, okay, 0.708 FCBC. Okay. So FCBC here, take outside. Somebody studying structure engineering. If you cannot do that much, I told not fit to see any class. So therefore, solving, we get FCBC. Those who want right here, that is the maximum compressive stress developed in concrete when given cross section is subjected to bending moment of 125 kilonewton meter. Oh, I have to calculate. Usually I get the answer ready, no problem. 250 into X into FC by 2 into 595 minus X by 3 plus 15.5 into 603.19 into 0.08 into 595 minus 48 reciprocal into 125 10 to the power 6. 8.4922. 8.4922 Newton per mm square over. This is a stress coming in concrete. Now do one thing, FCBC over. Now you need what? After FCBC, okay, now see, we got FCBC. To get FST, you can use M in terms of tension. You can make a note here. In single line post section, you have got two options. One, use this FCBC, use the relation between FCBC and FST, get FST. Or independently, use the expression for M in terms of tension. That is for singly. But in doubly, expression for M in terms of tension, nobody is using it. For some will tell it is impossible. It is possible. I will show it in the second part, next part. That is only for those who are interested. Only for those who are interested. Where I will tell for limit state method also now only. Because there is no guarantee. When I continue my regular course, when I reach limit state method, these numericals I may update in YouTube. I may not update in YouTube. Only selected part of my course I upload in YouTube. So that useful for public. Everything I can't upload because the course is going on there. So I will tell for limit state also. So what you do here, if you think that yummy expression in terms of tension is not there, it is actually there, I will tell you where. You can use what? Use relation between FCBC and FST. That is MFCBC divided by FST equal to X divided by D minus X. Okay. Substituting M 11 into FCBC 8.4922 why crackers now divided by FST you are finding equal to X 164.358 divided by 595 minus 164.358. You get the value of FST. Right here, what is FST? Stress developed in tension steel when the given cross section, if you want systematically, when the given cross section is subjected to a bending moment of 125 kilonewton meter. See, usually I think answer is ready. Today answer is not ready. Okay. 8.4922 into 11 into 595 minus X equal to divided by X. Something, I got 54,000. Something wrong. I got a common sense. 11 into 8.4922 into 595 minus shift store A divided by shift store A. 244.7589 or 759 Newton per mm square. So now you got the value of FST. Now anything further to be calculated? You have checked the question. What they want? They want maximum compressive stress in concrete. It will come at the top extreme fiber here because sagging DM. And what is the stress coming in? Tension steel. Over. One more thing required. What is the stress in compression steel? Okay, I will do that also. Now last, actually these are the two important. Still, okay, this I will remove now. Okay, this all I can remove. Nothing required. Okay, now lastly, if required, to find what? Stress in compression steel, that is in ASC. We already, right here, we already know that stress, right? You should write here. Stress in concrete at the level of centroid of compression steel is FC dash, which we got equal to 0.708 FCBC. Already you got from similar triangles. Now, right here, now you know the value of FC, you should write here. Earlier, FCBC was unknown. So FC dash we wrote in terms of FCBC. But now FCBC is known. So now right here. Now already FCBC known. Substitute that FCBC value equal to same 8.4922. This pen is not writing. Problem. Okay. I think I got more pens before coming to the class. Okay. This one we get FC dash equal to 0.708 into 8.4922. So what we got? We got stress in concrete. That is the stress in concrete here. Okay. Answer is 0.708 into 8.4922. 6.0125. 6.0125. 6.0125 Newton per mm square. Correct. See here. Extreme, if you have stress diagram, extreme fiber concrete will get how much? 8.4922. When you come down by D dash, it will reduce to 6.0125. Right here, this is not stress in compression steel. It is stress in concrete at the level of CG of compression steel. Now, theory of RCC. Therefore, stress developed developed in compression steel. Symbol is not required. Say FSC. FSC. But remember, this FSC is different for limit state method. FSC equal to whatever FC dash you got multiply by MC. Why? Stress in steel equal to M times stress in concrete. Some will tell, sir, MC minus 1. No. MC minus 1 is for equivalent area. But not here. Here MC only. Why? Modular ratio. There also MC only. Y minus 1. I told in the class. Where? Not YouTube class. In the regular course. So equal to FC dash 6.0125 into MC is 16.5. So you get stress right here. Stress developed in compression steel. Last one. 6.0125 into 16.5 is 99.206. 99.206 Newton per mm square. Over. So this will complete the question. See, this is Roman 1. That's all. I will close the class here and or end the class. Now what I will do is, next class is a special class. See, next actually you have to go for calculation of MR for WA in per section. That is Roman 2 you have to go for. No, I will do one thing now. Only those people who are serious and want what? Good information for them throughout the world. People will tell WA in per section, direct expression for M in terms of tension is not available for both working stress method and limit state method. I will prove that it is available, and there also I will get the same answer. It is my responsibility. Answer has to come same. I will get FCBC 8.4922, FST I will get 244, maybe 759 may become 758 or 761. This is almost what? 760, 761. That is because of rounding off error. And everything same answer will come there. My guarantee. Otherwise, sometime I tell, I will stop the teaching. If there is a liver arm, yes. If it is there, I will bring it outside. If the liver arm is hiding somewhere, or if that is hiding somewhere, I will pull it outside and show to you. And at that time, in advance, I will tell for limit state method also. So later, when for my regular batch, I will tell, see limit state method. Long back I told, it is in the YouTube. You can refer today and check the answer. Okay, now I will close this one. Next class, a special class only for concept. Other class will be how to find MR for WA in post section. Okay, thank you. We will meet in the next class.